Okay, let's take a look at section 9.6, special right triangles. First thing we're going to do is practice some Pythagorean theorem problems, and you'll see why in a second. Now, each of these triangles have one angle that's 90 degrees and two of them that are 45, as you see here. And they're just sketched in, but those are all 45, 45, 90s as far as the triangles go. So let's find the measure of this third side, which in all cases is the hypotenuse. So a squared plus b squared equals c squared. We're going to substitute in a 10 for our a and b, because those are our legs. 10 squared is 100 in both cases. Notice I keep adding down the left side. I don't say 100 plus 100 is 200, and then you get stuck. Then you have no variable left. So you keep working down the left, working down the right. Now we want to get the square root. Those cancel. C comes down. I get the square root of 200. Now for these problems, I could put that in my calculator and get an answer, but instead what I want to do is just break it down to the simplest form. So that's where we break it down into our perfect squares. So I'm making a little list here on the side. You may have them memorized by now, on and on and on. And I want to see what good 200 can be divided by. So these are all my perfect squares, and I work all the way backwards, and I know, because I've done this one too, that the square root of 200 can be broken down into the square root of 100 times the square root of 2. Square root of 100 is 10, square root of 2 stays the way it is, so my hypotenuse is 10 square roots of 2. Okay? Alright, now let's go ahead and do the next one. We have 3 and 3 as our legs, so a squared plus b squared equals c squared. We have 3 squared plus 3 squared equals c squared. It's going to be 9 plus 9 equals c squared, 18 equals c squared. Then I take the square root of both sides, get rid of the c, the squared. Square root of 18 we can break into square root of 9 times the square root of, square root of 9 times the square root of 2. Square root of 9 comes out, that's 3, and we have square root of 2. So my c here is 3 square roots of 2. Now in green I'll do the last one in that range. It's going to be a squared again plus b squared is equal to c squared. So I have 7 squared plus 7 squared equals c squared. 49 plus 49 equals c squared. 98 equals c squared. I take the square root of both sides. I find that c is equal to the square root of 98, and that can be simplified into the square root of 49 times the square root of 2. Square root of 49 is 7, square root of 2. So my hypotenuse here is 7 square roots of 2. Now the reason we practice with these is I want you to look at the first one, 10, 10, our hypotenuse is 10 square roots of 2. Second one, 3, 3, hypotenuse is 3 square roots of 2. And the third one, 7, 7, hypotenuse is 7 square roots of 2. There are these things called special right triangles, and one of them is a 45, 45, 90 triangle, meaning that when our angle measures on the inside are 45 degrees, and 90, our side lengths are always going to follow this pattern, and this is the pattern. Our legs are always the same, so x, x. And then whatever our legs are, our hypotenuse is x times the square root of 2. And that's it. So you don't have to work through all this work that I did. I could have just said, oh, 10, 10, that's got to be 10 square roots of 2. 3, 3, that has to be 3 square roots of 2. 7, 7, that has to be 7 square roots of 2. And work through it like that. Okay, so let's practice. We're going to skip down to the example 1, you try, and then we'll come back to the example 1. Okay, just grabbing my calculator. So, looking down here at the example 1 you try, we're going to practice some of these, putting it into practice. Ooh, whoopsies. There we go. So find the unknown length, write your answer in simplest form. Simplest form means we want the square root in the answer. If you round it, and you round it to the 10th or 100th, you put it in your calculator, that's not the simplest form, that's a rounded answer. So here, rather than working through the Pythagorean theorem, which we could do, I can say, oh, 45, 45, 90, 2, that's 2, this is going to be 2 square roots of 2. And I'm done. That's it. This one here, it's 45, 45, 90. I don't have two sides, so I couldn't use the Pythagorean theorem, but I could say, oh, if this side's 5, This side is also going to be 5, making this 5 square roots of 2. And that's it. So in practicing this is one of the triangles that shows up a lot, so this is a nice trick that you don't have to do all the work or extra problem solving. Here our hypotenuse is 9 times the square root of 2, so that means our legs must both be 9, and that's it. Alright, let's try example 1. It says, the mat used for floor exercises at a gymnastics competition is a square with a side length of 12 meters. So let's draw that. 12 meters on all sides. Gymnast starts at one corner of the mat and does a tumbling routine along the diagonal to the opposite corner. To the nearest meter, how long is the gymnast's path? So the gymnast starts here and she goes diagonally to the other corner. Okay, so they want to know how long is this distance that she's traveling. Well, because it's a square, that means each of our angles are 90 degrees. But whenever we cut this in half, this becomes 45, 45, and that one's 90. So we have this triangle, 45, 45, 90, which really would look something like this. This is 12, this is 12. This then, we have to find how long that diagonal is going to be. It's going to end up being 12 times the square root of 2, based on the 45, 45, 90 concept. So then the last thing is that here they don't say write your answer in simplest form, they say to the nearest meter, how long is the gymnast's path? So this is where we're going to put it in our calculator and find the square root of 2, or 12 times the square root of 2. And when we do that, we get the final answer, which is 16.9705, They went it to the nearest meter, so that would be 17 meters. So the distance across the diagonal of a gymnast's mat is 17 meters. Okie dokes, nice job. We're going to go on to the next page. In the final kind of part of this lesson, I'll come back. This is where we're going to do the theory up here. So I'll come back and go over that with you then. But